I get the pleasure of talking to everyone late in the afternoon when you're ready to fall asleep, but I promise you that you won't fall asleep. First of all, it's great to be here. I came here 2 years ago, as well as 5 years ago, so it's really fun to come back and to be with everyone. Today's talk is really going to be tying together all the previous talks. So when I was listening to Graham, when I was listening to John and Paul, I was thinking, wow, this is great because I can pull from their talks. It's really related to what I'm going to be talking about in mine. And the theme today of intelligence and testing, Paul and Graham talked about adding intelligence and testing to the people, right? And that's great. We also, John talked about AI stuff, right? So I'm kind of be combining all these together. So I think it's really going to be a fun afternoon. This is the LinkedIn me. You know, you can see me on LinkedIn. But I thought I would introduce myself from another perspective so you can see some of my experiences over the years. I started working as a young lad, about 3 years old, working in a factory. I worked in a factory, and we cut pieces of steel and put them together for buildings. And when I was working in the factory, I learned a lot about measurement, right? Because if you cut something incorrectly, that's thousands of dollars for a piece of steel. So I learned a lot about measurement. And then I went to work at a gas station. And I would fill people's gas tanks, right? And I would say, do you want me to wash your windows? And they would say, sure. And then I would wash the windows. But then what I noticed is that if I wash the back windows and I wipe the side windows, that maybe they would give me a tip. And really that was all about really understanding the user and users' expectations. And by satisfying expectations and understanding what they wanted, I was able to get 25 cents. So that was really good. Then I decided to move on from there, and I went to work at McDonald's. Anybody here worked at McDonald's before? No? Well, when you start off at McDonald's, you always have to clean the toilets. So I clean toilets, and I clean floors, wipe the tables at McDonald's. And then I got promoted, and I was able to make pancakes. Now you may think you don't learn anything about making pancakes at McDonald's, but you learn a lot about process. It's the process, you have this batter and you just go like this, and you press a timer button and beep, 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 beep. 30 seconds later you go like this and you flip the pancakes, and you hit the timer button again and beep, 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 and you put the pancakes in the container, right? So I learned a lot about process at McDonald's, as well as division of labor, because they always had the pretty girls at the front taking the money. So I wasn't allowed to do that. Then I worked at a shopping mall. And in the shopping mall, you know, they have these kiosks in the middle of the mall, and they sell things. Sometimes they sell things. Today they sell things like mobile phone, the case for the mobile phone, or things like that, right? Oh, we sold dried fruits and nuts. So I would stand there in the middle of the mall, and I would yell out into the mall, would you like to try a banana chip? And so I would lure the customers into the kiosk with a banana chip, and then I would try to sell them cashews and pistachios. Because the banana chips were $1.49, and the cashews and the pistachios were $6.99 and $8.99, right? So I learned about end users and how to bring them into our website and how to understand the paths and flows that they had going through the website by working at the nut store. And after all that, I decided to go to college, and that's why I'm here today. I went to college, luckily, and I was able to learn how to talk from the fruit nut store, and now I'm here in front of you guys. So it's great to be here. Mark Anderson has this quote about software eating the world, right? So I'll talk a little bit about let's talk a little bit about software, right? In 1956, they introduced the hard drive. Wasn't that amazing? Now we have, my phone has 256 gigabytes. Amazing. Then they had the personal computer. I couldn't find a picture of the Altair, but I put the IBM one up there. That was in 1975. And in 1981, they had the IBM PC, right? And I was born somewhere in there, but I won't tell when. Then they had in the 1990s, they had something called T3 speed, right? Wow, 45 megabits a second, that's so fast. Now we get that at our homes, even faster. And then they had what's called software is eating the world, right? And we had these derivative technologies. So if you think about those first technologies, then we have mobile and cloud. All these things come together because of that. We could not have mobile and cloud without good storage and good networks, right? And then we have all these sensors. We have sensors on our bodies, all our sensors in our mobile phones, right? And they start making all this data. And we want to collect that data, and then we started figuring out that, oh, we have problems in software development, let's be agile, right? So that brings us to today. We have a lot of problems in software development and testing, that's why we're here. So I'm going to talk a little bit about some of these problems, and can AI solve these problems? Maybe it can, maybe it can't. And how do we apply AI to software development and testing? Talk about some of the issues and problems that others have brought up already. But really, what I found in today's talk, a lot of people talked about what we need to know, what we should know. Well, I'm going to teach you what you need to know. What the real thing, the real know, the skill. Okay? Real quickly. So let's go over some of the intelligence that we need. So what are some of the problems that we have in software testing? Anybody want to volunteer? I'm going to come down here so that you can be a little closer. Who wants to talk about what are your top problems in software testing? The people from Malaysia, the Telecom Malaysia. What would be the top 3 things that keep you up at night about software testing? I know you think about it at nighttime, right?
Yeah.
Shakeout. Okay. What does shakeout mean?
It means that whatever that we have deployed that night, we have to do some testing after it is deployed.
Okay, do more testing after it's deployed, going from test environment to production environment and then testing again. Okay. Anybody else have a top problem in software testing? Timeline to do, not enough time to do QA. Okay, that's always a problem in software testing, right? So this is the problem, right? We have so many tests to do, right? And we're people. We just have to do our testing, right? Our testing capacity is linear. You can do 100 test cases. If we add her, she can do another 100. That's 200, right? That's linear. But then we have a lot of complexity. So we've talked a lot about complexity, right? Adding complexity to our software. I think either Paul or Graham asked, is software getting simpler? No, it's not, right? So we have an exponential, or even worse, maybe even a power function as far as the number of increasing test cases and tests that we have to do, more third-party modules, more test environments, right? We have more stuff to do. So there's this huge gap in what we can do and what we have to do. And then we're human. We make mistakes, right? We're writing code. If we have Agile, that's great. If you guys can work together and write code, but what if we have people in different parts of the world? That adds different levels of complexity. Then there's maintenance problems, right? We write automation code, and we have to fix the code. So who has time to fix code? I hate to work on my lawn, so I don't have one. I don't have any time to fix code. Then we have problems in object recognition, right? Recognizing these objects on the screen, putting it into our code, and then we discover, oops, the object changed. So we think we're really smart, right? As developers and testers, we have some problems. Back in the old days, in our primordial origins, we would see a tiger. We would hear some bushes, and what's that over there? And we would run right away, right? That is a natural reaction that we have to certain things. And we would do, okay, this means I should run. Or, this means I should eat sugary foods because it gives me calories that I need right away. These are early things in our origins that we do automatically, right? These are really biases in our thinking, and they cause us sometimes to make mistakes and bad decisions. Do you think that the more information you have, you can make a better decision? Not always. A lot of times we think that, oh, the software is not ready for release, but maybe it is. Maybe we're not going to really discover any more bugs than we have. Or maybe the bugs that we just do discover, maybe they don't matter. So there's lots of cognitive biases, and if you want to download the slides later, these are the top 10 that I like to talk about, but I'm only going to talk about a few of them. The first one is anchoring, right? Does anybody know what anchoring means? So a lot of times we're anchored to a number or an idea. One example is like at an auction. Suppose I want to auction off my watch. And I say, well, who wants to buy this watch? Who wants to buy this watch? $500? Anyone want to buy this watch? $500? $500, right? The bidding starts at $500. Somebody may say $525, right? But really, I only bought this watch for $50. That's pretty good. But I'm anchoring that $500 number in everybody's mind, and they're going to start at $500 just because I anchored their mind at $500. Another example of biases is availability. The availability of information on our brains in the top of our minds, right? So, I just ran into a friend that's 85 years old, and he smokes a lot, but geez, he's 85 years old. I guess smoking is good for you. Right? That's in the top of my mind. Smoking must not be bad for you if I have a bunch of friends that they're smoking and they're old. Must be okay. That's the information that's in my brain at the time. Here's one about the information. If you were to, say, count up 3 or 4 characteristics of a house, maybe the number of bathrooms, the square foot, and the location, those 3 things, that would very accurately tell you what the price should be. You don't need any more information. That will give you a really good idea of the price. Recency. A lot of times we think that the newest information is what's true. And we tend to ignore all of the past information just because this recent information is in front of us. So what kind of information would that be if we're testers? Oh, we found a bug in this module. But really, in the past, all of these other bugs, we need to consider all these other past bugs, not just this bug here, right? When we are thinking about our testing strategy. And of course, the outcome bias. Just because I go to the casino and I win, doesn't mean gambling is a good way to make money. So, there are some areas that artificial intelligence can help us to avoid these biases. We've talked about how we need data, right? So if we can get artificial intelligence to look at the data and get rid of some of these biases that I just talked about, then maybe they can help us. But let's talk a little about what artificial intelligence says. Does anybody here know the difference between machine learning and artificial intelligence? Not the doctor. Who knows the difference between machine learning and artificial intelligence? Actually, they're subsets of one another. So machine learning is part of artificial intelligence, and deep learning is part of machine learning. So if somebody asks you the question, what is the difference between artificial intelligence and machine learning? That's not the right question to ask. Here's just some mumbo jumbo that I'm not going to, read out for you, but today's artificial intelligence is mostly about machine learning. And so we're going to talk about machine learning in depth today. And then once we have a good understanding of machine learning, then we're going to say, okay, where can we apply machine learning to testing? And I did this little research on Google to think about, okay, let's think about artificial intelligence and machine learning. You can see that machine learning is just off the charts compared to artificial intelligence. Most people are interested in machine learning as part of artificial intelligence, as one of the aspects of artificial intelligence, right? You can see that it's been around since the 50s, actually. John was telling me over the break that he worked on artificial intelligence, and I said, yeah, you worked on it back in the 1950s, huh? And he said, yeah, that's right, I did. I took this out of the Gartner hype cycle, and what's interesting, over break we also talked about the future of artificial intelligence. What's interesting is you see these terms, again, that we're learning, right? Artificial auto machine learning, we've got natural language processing, right? We have data labeling, which is really understanding the data. We also have computer vision, which is really object recognition, right? And lastly, you can see that they're all 2 to 5 years in the future of really getting a good amount of implementation penetration. This is a real basic model of machine learning where you take in data, and people have talked about this a lot already, taking in data, developing a model, testing your model, seeing if you're right or wrong, using these right or wrong evaluation results, and then retraining your model, right? You've probably seen this little graphic many times. And I believe Nishi talked about the importance of recognizing the biases in your data as well as in your model too. So testing artificial intelligence really is based on looking at your algorithm, looking at your model, and looking at your data. So now we're going to have a little class. I call it Artificial Intelligence 101. Okay. So here's the next generation of definition of machine learning is a computer program is said to learn from experience E with respect to some task T and some performance measure P if its performance on T as measured by P improves its experience. So, for an example, an email program that watches emails, right? And then they're watching whether or not you mark it as spam or regular mail, right? And based on that, it's learning, okay, this guy considers this to be spam or this not spam, right? What is T? Does anybody have the answer? What is the task? What is the task that the machine is trying to do? Raise your hand. Raise your hand. What's that? I'm sorry, Kim. Filtering. Right, okay. So the task, okay, so first one, the E, which is the experience, is it's watching you. It's watching all this data coming in. That's the experience, right? It's marking it as spam. That's the P. That's spam or not spam, right? And the last one, what you were saying, is filtering the email, right? So you have these tasks and the way that machine learning learns things. And that's important to remember, because when you start learning these machine learning tools, you have to know these kind of methodologies and nomenclature. Here is a brief chart of machine learning, of the different kinds of machine learning. There's others that go on top of this or to the side of this, but I'm just going to talk about these today, because I think they're really important. As you start digging into some of these machine learning tools, it's important to understand this. This is one type of machine learning which is called regression, supervised learning, and it's called regression. It can see that you have an input, right? This is for calculating a housing price, the example I used earlier. You can see you have an input on the number of square meters, and you have an output, the predicted net price, right? So it's supervised because you know the price. Based on your data set, you have the price, and you have the number of square feet. That's supervised. It's also a continuous value of output. So it's not a 0 or 1, it's continuous, right? So you have 88 meters equals this price. You get 89 meters equals a little bit higher, right? Something like very continuous. The other type of supervised learning is called classification. So you can see you have these different tumor sizes up here. Based on the tumor size, I'm saying, okay, well, this is malignant, this is a bad tumor, or this is benign, not a bad tumor, 0 or 1. So that's supervised learning, because you know the input, the size of the tumor, and you know the output, yes or no, bad or good, right? Supervised and classification. Note that your classification could be 0 or 1, bad or not bad, or it could be maybe 3 values, or maybe it's 4 values. So you could, for instance, in analyzing a defect, maybe you would say it's severity 1, severity 2, severity 3. Based on some things that you input into the model, you would be able to tell whether or not it's severity 1, 2, or 3. I could also represent this data like this on the bottom chart, where I've taken this data and transposed it into something like this, right? Then I can add another classification on the age of the patient, and I can add another dimension into my data. Right? So I have tumor size. I've also got benign or malignant with the age. And I can kind of separate that, right? Over here, of course, there might be some exceptions on the blurry area. Over here is good tumors, over here is bad tumors. Right? So what other factors of looking at that tumor would I consider besides the size and the age of the patient? Well, maybe I would consider, if it's squishy or not, right? Maybe I would consider things like the density of the tumor. Maybe I would consider things like the shape of the tumor. All these little things that I have to think about as input into my model. Many other things. The thing is, then there's what's called unsupervised learning. So if I just take a bunch of data, classifying it, making some sense out of it, even though I have no idea what it is, that's called unsupervised learning. So, pop quiz. The pop quiz question is, John, you better pay attention. We want to examine all of the priority 1 defects and predict how many will get fixed before the next release. What kind of learning is this? We want to examine each defect and determine if it is priority 1 or priority 2. Those 2 questions. What kind of learning should we use here? Remember, we're going to be putting these things into our model. So what kind of machine learning algorithm, because we're going to be using, according to John, we're going to be using some of this software to examine these defects and figure out what to do here, right? What kind of machine learning is this? What kind of algorithm should we check off in our machine learning software to tell us what to do? You have to be able to figure out what algorithm, right? Well, let's see. Number 1, we want to examine the priority 1 defects and predict how many will get fixed. Well, that's definitely a regression problem because that's going to be a linear function. Does that make sense? How many will get fixed? Well, it could be 72%, could be 77%, right? That's a linear thing. The next one is, we want to examine each defect and determine if it is priority 1 or 2. That's just 2 answers, right? So that would be a classification issue. You want to look at the defects, you want to look at, say, these 5 characteristics of the defect. You want to say, okay, this is really high priority, and this is not high priority, right? So that's a classification issue. Extra credit. Anybody want extra credit? Okay. What type of machine learning is used for object identification? I'll let you guys think about that one. I won't ask you. No right answer. Okay, so let's look at some common applications, and we've learned now that we know a little bit about machine learning, we can say, okay, well, we understand how these kind of things work, don't we? And we understand these things. At least I think we understand. Now this graph was put up by a couple other folks earlier today. Now we understand this a little bit. So we have inputs, right? What would inputs be? For example, let's say, okay, what would be the characteristics of defects? What are the characteristics of test cases that we have? What would you say would be 5 or say 3 or 4 different characteristics of defects that are important? Anybody want to volunteer? Don't raise your hands too quickly. What would be 5 key characteristics of defects that we want to look at and put into our algorithm? Well, one of them would be, what? Is it how fast, how many times it occurred? Maybe that would be important. What other characteristics of defects are important? Say again? The impact, okay. That's a good one. So we want to collect characteristics of defects, right? We want to put it through some model. And the model would be what? Maybe it would be a supervised learning model with regression. Maybe it would be unsupervised. Maybe we're just trying to find relationships of the defects. We're just trying to put them into buckets and analyze them. And then we have the output. This is a good defect, or this is a bad defect, or different things like that. So I invite you to think about the different areas of software testing where we could take characteristics of stuff in our input, put it through a type of machine learning model, and come out with something, right? This is real stuff for us as software testers. So here are some of the questions that you may want to ask your machine learning or artificial intelligence to do, right? So let's think about how can we apply AI. Now when I say AI and machine learning, you know exactly what I'm talking about. You know that I'm talking about really machine learning, right? Because you know the differences now. Right, so the problem with automation is what? Recognizing the objects, code changing, things like that. So in our office, we tried some of the more recent modules, and I won't mention any vendors, but we found that there was a big issue with trying to recognize these objects intelligently, and there was a big error rate. 30% of the time it made a mistake. And we also had problems training it to learn new things. So first, you have to identify whether or not the mistake was made, and because there's no, sometimes you know the test oracle and sometimes you don't, right? And then training it is also a big issue. So taking your data, analyzing the data, correcting your model, and training the model to do a better job is often very hard. Test generation, very, very difficult, right? And so we're trying to figure out what the user is doing, and then we want to put it through some model and develop some testing. Oh, shoot, that's not what I was supposed to develop, right? Test generation is very difficult. Observing user behavior, developing flows for the user, right? But we can do that a little bit now with some of the existing software out there, and I'll talk about some of the vendors in a minute. And then there's machine learning by observing testers themselves. Turning on recorders, taking these recorders of a person that's a software tester and converting these into test cases based on what software testers do. This is from a very large Chinese internet company. I won't mention what Chinese internet company that is. But they're actually applying artificial intelligence to their developers, trying to help their developers to write better code. Figuring out, well, this developer makes these kind of mistakes by looking at their code. And actually providing autofill solutions, the same way that we have autofill in our forms, or now on Google Mail, you can see that it tries to fill in stuff for you that they think that you want to do. They're actually doing that for developers to help them to avoid mistakes. Predictive analytics, people have talked about this earlier, about predicting things, right? Predicting where the defects are, predicting whether or not your software is ready for release. So, what would be different characteristics or input that you would put into your model to determine whether or not the software is ready for release? So I invite you to think about that. Right? And what type of machine learning would you apply to that? Do you want a 0 or a 1? Or maybe you would want kind of like a mixture. Maybe you would want a probability of a 1, a probability of a yes, a probability of a failure, right? So you would have to combine your knowledge of the two different types of supervised and unsupervised, or regression and classification. You would combine those two methods into one. Does that make sense? And of course, AI needs data. The same way that our power plants need coal or gas or something like that to produce energy. AI needs data, right? Data is the input into all AI. Without data, we have nothing. This is another chart from a very large Chinese company. You can see that data is at the center. Data is at the center of their strategy. And I think data is really becoming more and more important. If we don't have data, what are we going to do with artificial intelligence? Has no meaning without data. right? Actually, as I was discussing with John, we had artificial intelligence algorithms, we had all of these ideas back in the 50s. But we had no data, and we had no computing power. Now that we have these things, then we have a way to move the data around because we have telecommunications networks, right? So we need to have data in order to have AI, and we need to have data as a critical part of what we're doing in our businesses and in software testing. And as I was saying earlier, we need to be careful and think about how we train our machine learning, how do we train our AI to deal with the data and correct the data, correct the biases in the data, as well as in our models when we make mistakes. So, Houston, we have a problem, and I put this big elephant here because that's kind of the elephant in the room, that everybody is so excited to implement AI, but they don't realize that, geez, maybe our data is bad. We really need to take a really close look at our data. And there's different problems in data. There's biases in data. There's incomplete data. Many different data issues. Spam data that's an easy one, right? But look at this. They recently, that's what the deep fakes comes from, right? How do we avoid deep fakes? Google recently released a data set to help people to get rid of deep fakes. Isn't that that's good and that's bad, right? And then we have facial recognition biases. Just recently, only a few years ago, everybody knows this, but I'd like to bring it up anyway. Only a few years ago, Google made a mistake and identified black people as gorillas. And you know how sensitive Americans are to racial stuff, right? It was really a big deal. Bad data set. And then we have autonomous driving. People dying because of bad data or corrupted data. If you can move the lines around, I was just thinking as Nishi was showing that video, I was thinking to myself, geez, if I was a criminal and I was trying to get away, say 10 years from now when they have artificial intelligence, what would I do? Well, I would spray the road with paint behind me. I would spray paint all over, and nobody could identify where the roads are. And then there's the problem of the turkey. Some of the Americans that are here, I know John for sure knows, we eat turkey at Thanksgiving, right? Turkeys take about 150 days to mature. At 150 days, they can get really big, maybe 5 or 6 kilograms, just in 150 days. So if I'm a turkey, I'm thinking to myself, well, John came and fed me today. And then the next day I get a little bigger, and John came and fed me again. I get a little bigger. 150 days in a row, I get fed every day. The problem is I don't know what happens on the 151st day. So my data set is I get fed every day. I'm just going to eat my food, right? That's great. The problem is that I don't know what happens on the 151st day. All along I'm thinking, okay, my data says I'm going to get fed today. I'm going to have a good night's sleep. But all of a sudden, I get eaten. I get killed and eaten. My data set says everything is okay. I'm going to keep eating every day. But all of a sudden, I get killed. And that's really what's called the black swan problem, or something that's called silent data. So if you think about it, when you ask a bunch of entrepreneurs about, how they became successful and something like, how great they are, they'll say, oh yeah, But you don't hear about all of the entrepreneurs that were unsuccessful. The reason you don't hear about them is because they don't talk. That's a lot of silent data. The percentage of successful entrepreneurs is like that. But you don't hear about all these guys that are not successful. That's silent data, and we're really guilty of not acknowledging that silent data. And that's a problem with data sets in AI, like the turkey found out. That's a problem in the data set. So I'm going to kind of talk a little bit about the problems of this data set, is that most of us really assume that life goes according to what we call the normal distribution. Everybody knows the normal distribution, right? When we get grades in school, at least in the United States, we're graded according to what's called a bell curve. Most people get C's, very few people get A's, and very few people get F's. That's called the normal distribution. But the normal distribution has some interesting characteristics. The first characteristic is that 68% of the people lie within one standard deviation, right? 95%, that's a lot of people, lie within two different deviations, and almost everybody lies within 3 deviations. So let's put that into perspective in terms of some real information that you can really get your hands on. If we were to take, for instance, the weight of everybody in the room, we would come up with an average, and we'd have one standard deviation, maybe it's a few kilos, next standard deviation, a few more kilos, right? What would 3 standard deviations be for that? It would be 99.7% of the people were between 48 and 72 kilos. That's a pretty small range, right? If we were to look at software development, what types of things would be the normal distribution, which would be like a blue distribution? But what types of things would be more flat, where you have a lot of people that are 70 kilos and a lot of people that are 30 kilos? Right? There aren't many people in here that are 100 kilos and 30 kilos, right? Because it's a very steep curve like this, right? Everybody is between, say, 50 kilos and 75 kilos. So if we were to take height, you see, this is actually real data here for the United States. You see very few people that are over 6'10". I think that's probably about 2.1 meters, something like that. Right? That follows a normal distribution. A lot of people in the center, not many people on the edges. So when you think about your data set, when you're examining your defects, when you're examining your test cases, think about, well, is this really flat or skinny? How would I analyze this data to put into my model for machine learning? Right? Here's an example that's not a normal distribution. You think about book authors making money. You think about movies that make money. That is a really wide standard deviation. Does that make sense to you? There are some movies, 1 or 2, that make a lot of money, and everybody else makes a little money, right? So if you were to take a standard deviation of movies, you'd see that, oh wow, there's $26 million for the average, but that's averaging in all the zeros and $10 movies with the $1 million movies, and you have a very, very wide standard deviation. Much different than analyzing the heights of people in the room. And so I invite you to think about the types of data that we're analyzing to put into our machine learning models. Now I've told you about we've talked about data, we've talked about different characteristics of data, we talked about models. Now you know, well, geez, these are the mistakes that I need to think about when I'm putting in the data into the model, right? This is a picture I took recently in China. You can see They call China the surveillance state, right? It's amazing how many cameras they have everywhere. And they're just, they've actually made facial recognition illegal in the US as far as using it for law enforcement, because they think one of them is privacy, the second one is making a mistake, right? But in China, they don't care about that. They care about catching the 99%. And the thing is, how can we get from there to utopia, right? How do we get from there to utopia with robots all doing the right thing? What could go wrong, right? And how can we trick AI? I talked about putting paint on the road so the guys can't follow me when I'm getting away. But how could you trick AI or how could you look for bad data in your data set, right? That's the same thing as tricking AI. And where can we use it in our development lifecycle? We can do DIY. So I've listed here a bunch of libraries that you can use. There are a lot of Python libraries that you can use to pull into your programming for AI to analyze data. I call it DIY, right? It's fantastic. There's the amount of information that's out there to draw from, to use these algorithms. Each one of these may have different types of algorithms, like we just talked about today, like you learned about today. And then there's tons of vendors now, right? Each one of these, now you know kind of a little bit what these guys are trying to do. Some of them specialize in object recognition. So what would be the parameters of input in the data? They would look at this data of the object, and they would output, this is a home button, or this is a menu, or something like that, right? Now you know kind of how all that stuff works. So where do you want to go today? That's me. I'm really passionate about cycling. That's me, and that's I can't even remember where it was. I think it's in Oregon. So where can we use AI and machine learning and software testing? I hope that you've gotten a good flavor for that today, right? Where can we use this stuff? How do the models work? How do we look at the data to put in the models, right? And the second question is, how would you do QA for AI, which is what Nishi talked about earlier today. Now you know a little bit about data and the fallacies of good and bad data. Don't be a turkey. And then, of course, you know some of the drawbacks of using machine learning. Errors in your data and errors in your model, and being able to train your model. And that's it for today. So thank you very much. I hope that you've learned a little bit, and I'll see you tomorrow. Thanks. Does anybody have any questions? Forgot. Anybody have any questions? No? All right. Oh, a question there. Yeah.
What about not normal data? Like data is not distributed normally. So
Well, the thing is that a lot of machine learning models are trained to throw away outlier data and throw it away, right? So the question is, do we actually put that into our model, and how much weight do we assign to that in our models? Anybody else have questions? All right, well, thank you for attending and listening and staying awake. I know that you want to go home and fight the traffic to get home, so thank you again.